Assalamualaikum warahmatullahi wabarakatuh. My name is Mursyidah, Binti Waruna, and I use Mohd Munzir, matrix number 071891. So in today's presentation, we will explore the topic of sustainability and the environmental impact of data centers. And this is the team members for our group project. Now we move on to the introduction. As cloud computing continues to grow, so does the demand for large-scale data centers. So these facilities are essential for storing and processing data. So with more people and organizations using these cloud services, the need of data centers is increasing rapidly. So this rapid growth raises one important question. It is how can we build a sustainable and a friendly environmental infrastructure that can support the future of cloud computing without harming the planet. So in this presentation, our group will focus on one major environmental challenge related to data centers and propose strategic solutions to address it.
My name is Siti from Sahidi and my number is 073377. Next, we will continue with background organization. Okay, so for our group, we have chosen Microsoft Azure as a real-world organization. Microsoft Azure is a cloud platform introduced by Microsoft in 2010. It provides a wide variety of services such as networking, computing, and storage to business all over the world. Azure has operated in over 60 regions with more than 200 data centers, making it one of the most globally available cloud platforms. It also stands out for its strong support for the .NET framework, high security, and hybrid cloud capabilities. It also offers flexible pricing and globally recognized certificate programs, which makes it accessible to both companies and individuals. Despite that, Azure also faces some sustainability issues such as high energy use, carbon emission, e-waste, and also water consumption. Tackle these, Microsoft has pledged to utilize the renewable energy by 2025 and also become carbon negative and water positive by 2030.
So for this part of presentation, I will be discussing the major environmental issues related to cloud data centers and identifying the key issues we have chosen to focus on. As the demand for cloud services continues to rise globally, several sustainable concerns have become more critical. The main environmental issues discussed in our research include high energy consumption, which is data centers require a large amount of electricity to power servers and cooling system, and over-provisioning often leads to waste energy. The second one is carbon emission. When data centers rely on fossil fuels like coal and natural gas, they generate significant greenhouse gases which contribute to global warming. Next one is water usage. Cooling system in data centers, especially evaporative cooling, use massive amount of water which puts stress on local water supplies. Last one is electronic waste, which is e-waste. Frequent upgrades and replacement of hardware generate a lot of waste, which if not managed properly, harms the environment. Among these issues, the one we have chosen to focus on is carbon emission. This issue is especially important because many data centers are still powered by fossil fuels, particularly in regions with limited access to renewable energy. For example, in Virginia, USA, which has one of the highest concentration of data centers, the electricity supply is still heavily dependent on coal and gas. This leads to a high carbon footprint even with modern technologies in place. The environmental impact of carbon emission is serious. It contributes to climate change, affect global efforts like the Paris Agreement, and creates reputational risks for companies that rely on unsustainability cloud services. That's why tackling carbon emissions has become not just an environmental responsibility, but also a growing strategic priority for cloud providers and their customers.
My name is Nik Farhain, Binti, Nik Mat Yusof, and my metric number is 071958. In this slide, I will explain and compare 4 key sustainability tools provided by Microsoft Azure. First, the Microsoft Sustainability Managers. This is a centralized platform that tracks the environmental impact of operations using Scope 1, 2, and 3 emissions. Scope 1 refers to direct emission like from Azure's own data center generators. Scope 2 cover indirect emission from electricity that Azure purchase. And Scope 3 include emission from the wider value chain such as supplier operations, logistics, and how customers use Azure service. This tool provides detailed ESG dashboard, but it needs proper integration with external data source. Next is the Azure Carbon Optimization tool. It helps reduce emission by identifying inefficient workloads that can be improved. It works well with Azure Advisor, but it's still under development and not fully available across all services. The third tool is Azure Advisor. It now includes sustainability suggestions that help user optimize performance and energy usage. It's user-friendly, but sometimes the advice can be too general for complex workloads. Lastly, we have Azure Data Center Innovations. Microsoft is improving its physical infrastructure with green technology like liquid cooling and has committed to using 100% renewable energy by 2025. These upgrades are impactful, but they are handled fully by Microsoft, so users have limited control. Together, all these tools show Azure's strong commitment to sustainability and support its legal goal to be carbon neutral by 2030.
My name is Nurain, Shuhadah, Binti Amiruddin, and my metric number is 074579. Our proposed solution is called carbon-aware load shifting. One major sustainability issue facing Microsoft Azure is that some Azure data centers still rely on fossil fuels such as coal and gas. This results in high carbon emissions in certain locations, and it threatens Microsoft's carbon neutrality goal by 2030. To address this, the cost solution we propose is carbon-aware load shifting. This means we dynamically reroute workloads to low-carbon regions, for example, to countries like Sweden, which use hydropower, and avoid regions like Virginia that may currently rely more on fossil fuels. This routing is based on real-time carbon intensity data, which helps us to choose the cleanest energy source available at any given time. To implement this solution, we need a few important tools. The first tool is the emission impact dashboard, second, carbon tracking APIs, third, Azure Resource Manager, and lastly, Azure Traffic Manager and Load Balancer. Let's now walk through the implementation plan in Azure step by step. Carbon data integration, we start by using emission impact dashboard and carbon tracking APIs to get real-time carbon states. Policy definition, we define carbon intensity threshold using Azure Resource Manager to decide where workloads should or should run. Orchestration connection, next we feed carbon data into Azure functions and logic apps. This enables smart routing decision in real time. Load distribution tools, we use Azure Traffic Manager and Load Balancer to redirect workloads to the most sustainable data centers. Complex checks, we also perform region-specific checks to follow data severity rules and make sure everything stays compliant. Performance testing, workloads are tested across different time zones to ensure both low latency and high availability. Monitoring, we continuously track CO2 saving through dashboard to evaluate the impact. Optimization, finally, we continuously tune the system based on real-time energy trends to keep improving carbon efficiency. In summary, carbon overload shifting help Azure reduce emissions, meet compliance, and support Microsoft's sustainable goals, all while maintaining performance and measurability.
Let's proceed with the architecture solution. The figure shown right now is the architecture for our proposed solution, which is carbon overload shifting in Microsoft Azure. The goal is to reduce carbon emission by automatically sending cloud workloads to data centers that are currently using cleaner energy, such as wind or hydro. Let's start from the top of the diagram, where the system will receive requests from user or application. This request could be web application, APIs, or batch processing jobs that need to run on Azure. When the user sends a request, it will first go through the Azure front door, which acts as the global entry point. It handles routing, security, and high availability to ensure that the request is distributed properly. Then, the traffic is passed to Azure Traffic Manager, which is responsible for geo-routing and failover. This component plays a central role in identifying which region should handle the workloads. Instead of just choosing nearest or fastest data center, it now considers carbon intensity. There are three regions shown here. Region A represents the high carbon area, such as one that powered by coal or gas. Region B represents low carbon area, such as region that mostly use hydropowers. Region C is moderate, depending on its energy needs. Before any workload assigned, they first pass through Azure Resources Manager integrated with AI-based logic app or Azure function. This layer applies carbon aware policies by referencing real-time data from Microsoft Carbon Monitoring APIs. It examines the current carbon intensity in each region and then determines where the workload should go by prioritizing cleaner region. These analytics will help Microsoft to monitor the proper system performance. Once a low carbon region is selected, the workload is sent to Azure Compute Services. After workload completed, the system will log the carbon saved using the emission dashboard. These tools track key metrics like the amount of carbon dioxide saved, the average of carbon intensity per workload, and how emission has changed due to load shifting. Overall, this proposed solution architecture lets the user make smarter and eco-friendly decisions by automatically shifting the workloads based on real-time carbon data and also maintaining performance and reliability at the same time.
In conclusion, carbon emissions from data centers represent a critical environmental challenge that must be addressed to ensure the long-term sustainability of cloud computing. So this is because the emissions contribute significantly to global climate change, hence creating a barrier to meet the international sustainability goals. So to reduce the carbon footprint from data centers, it requires coordinated efforts from all stakeholders, including cloud service providers, government regulators, and end users. By prioritizing sustainability and investing in a more efficient technologies, the cloud industry can evolve in a way that support both digital innovation and environmental responsibilities. So ultimately, addressing this issue is essential to minimize the environmental impact of data centers and to move towards a greener and a more sustainable future. So that's all from our group. Thank you.